Okay, so in this video, I want to talk about two properties of equality that we're going to be using in order to help us solve these linear equations in one variable. Okay, so these are some of the tools that we're going to be using. So two properties here. So one of them is the addition property, right, of equality. And we have the multiplication property of equality, right? And in order to use these properties, right, you have to have an equation, right? Hence the word equality, right? Two things have to be equal. So we have equality here. So let me just circle that's important, right? So need an equal sign. So here is my equal sign right here. And, A and let's just use A and B. And again, they can be numbers, real numbers, or algebraic expressions, or a combination of both. I'm going to be doing a bunch of examples, so don't worry. I know this is a little abstract. So if A equals B, then this property says if I add, okay, if I add both sides, right, of an equation, right, to the left and to the right, it's not going to change the solution set. And solution set, I'm in quotes, I'm going to be talking about in just a bit. So if I, let's see, maybe use a different color here. So let's say I use, oh, okay, I'll just use blue. If I have A and I decide to add B, I hope you can see that. Just kidding, not B. We already have B. Let's say I add a C. Okay, so notice the only new thing that I did was I added a C to both sides. Okay, this equation and this equation have the same solution set. In other words, I don't I haven't changed anything, right? If okay, so examples here. If A is okay, A is Jasmine in the class, and B is David. Okay, so Jasmine and okay, so here's Jasmine and here's David. Okay, if Jasmine and David okay, equals, meaning Jasmine is not equal to David. So here I'm talking about money. Let's say Jasmine has $10. Okay, here we go. Jasmine has $10, okay, and David also has $10 in his pocket. Okay, obviously 10 equals 10. Now, if I give $2 to Jasmine, okay, and I also give $2 to David, right? You can do this vertically. Are they going to have the same amount of money? Well, yeah. I mean, 10 plus 2 is 12, right? 12 equals 12. So I didn't change anything. Now, similarly, you can subtract C from both sides, right? I can take away $2 and then Jasmine and David will both have $8. But notice that they don't have a subtraction property of equality. It's because technically there really is no subtraction. We're really just adding negative numbers. I mean, when you pay bills, right, or you're in you owe $5 and you owe $7, and then you go to another store and you use your credit card and you owe another $5. I mean, what's really happening is you're adding up these negative numbers, right? You're adding this debt. So that's why, I mean, addition really in subtraction really is embedded in the addition property of equality. So that's what that means. Okay, so multiplication property of equality, and notice they don't have a division property of equality or quotient, which means division. So this is very similar. A equals B. And so, okay, well, I already used Jasmine and David, so I'll just keep Jasmine and David here. So multiplication property, if let me use maybe a lighter blue here. So if I decide to multiply C, right, to A, right? There's really a dot there, and C to B. Okay, again, this equation, right, is still, I haven't changed anything besides the value, but these guys are exactly the same, right? I mean, again, 10 equals 10, right? Well, if I multiply it by, oh, I don't know, 2 times 10 equals times 10, right? I still get 20 equals 20, right? They still have the same amount, amount of money. Okay, so I want to do another quick example or explain this property because this is very important and it's connecting it to your rational numbers that we just finished talking about. So let's say, oh, okay, again, let's use the same example. So 10 equals 10, right? Obviously an equation. So again, Jasmine has $10 and David has $10, okay? Well, I mean, I multiplied by 2. Well, I could divide by 2 if I want to, right? I'm allowed. If I divide by 2, I divide by 2. Okay, well, half of 10 is $5. Half of 10 is $5. Okay, they still have the same amount of money. I mean, think of this as a scale, right? If you have a scale, your little, or like the little, I'm thinking of a playground, right? That little, what do you call it? The little seesaw. I don't know what it's called. Right? Somebody, is sitting up here, or somebody's sitting at here, and, right? It goes down, it goes up. But you want to balance it out, right? You want it to be, you want it to be equal. So that's what you're doing. I mean, if you add, 5 to both sides, you're trying to make them equal. Okay, so going on a tangent here, I'm getting excited. Okay, so we have this, okay, this divided by 2, very important. Again, there's no division property of equality, so why am I allowed to do this? Well, this is really saying, again, I'm writing my 10 equals 10, right? Remember, dividing by 2 is really, another way of writing this is, so this is what I'm trying to say, 1/2 and 1/2, excuse me, right? If I divide, I mean, this is just another way of writing it, right? Half, what's half of $10? Well, whoops, it is 5, and the right-hand side is the same thing. What's half of $10? 5. So, I mean, we still get 5 equals 5, but I want you to see that when you divide by a number, you're really multiplying by by the reciprocal, right? 1/2. The reciprocal of 2 is 1/2. So that's why, again, there's addition and multiplication. So when you, again, divide by 2 to both sides, you're really multiplying by 1/2. Okay, I know that was a little bit long, but very, very important properties that you should understand. There's a nice little table, table 6.1, page 351, which kind of gives you an example of each, especially the last one, which is you're using the property of multiplication. But I'll go ahead. I'm gonna do a lot of examples. So hopefully this helped